Bismillahirrahmanirrahim. Hello everybody. This is a new video about extremum, bounds, supremum, infimum, minimum, maximum if they exist. So, how we can deal with this set? I think that it is preferable if we can transform it like this. So instead using this formula, I prefer propose this formula. I mean this term is equal to 1/2 minus 1/2 2 times n over 2n plus 1. We add plus 1 and we take off 1 minus 1. And this will be equal to 1/2 times 1 minus 2n plus 1 over 2n plus 1. This means minus 1. And minus with minus means plus 1 over 2n plus 1. So this will, and we keep. So instead using this one, which is a little bit long, I prefer use this one. It is the same thing. So thus we transform it to this one. For n in NO, which means natural number starting from 0. Okay, let us get started. Two ways. We can use sequences and we can use sets, technique for sets. I will use technique for sets just until we arrive to the chapter about sequences. Okay? We have 2 times 2n plus 1. First, I should verify that this is not empty. For n equal to 0, we have 1 over 2, and this belongs to A. So A isn't an empty set. This is first of all. Then we have 2 times 2n plus 1. This is greater than 2 for any n in n L. This implies that 1 over 2n plus 1 is less than 1/2. And this is a positive number. Thus, 0 is less than 1 over 2n plus 1, which is less than 1 over 2. Therefore, A is bounded, just like this. Sorry. So A is bounded. Why? Because for every n in natural number, we have this bounds, simple logic. From this point, we suspect that infimum of A can be 0 and the supremum of A can be 1/2. We just suspect, we are not sure. To be sure, we need to use the characterization of the infimum and the supremum. Okay? For any element an from A, we have an is less than 1/2. Actually, is less than or equal. So we can take this. Why? Because for n equals 0, it is equal. For n equal to 0, this is greater than 2. Greater than or equal to. This first. Second, for any epsilon greater than 0, can we find an A epsilon from A such that what? Such that 1/2 minus epsilon is strictly less than A epsilon, which is less than or equal to 1/2. This is done. So we are just interested in this inequality, strict inequality. Cases. If epsilon is strictly greater than 1/2, greater than or equal 1/2, this is true. Why? This is trivially true. Why? Because A epsilon take the form 1/4n plus 2, this one, and this is a positive number. Any given strictly positive number is greater than any given negative number. So this is true for all epsilon which is greater than or equal to 1/2. If epsilon is less than 0 and greater than less than 1/2 and greater than 0, we can deal with this case. 1/2 minus epsilon less than what? Less than 1/4n plus 2. This is true. So we start from this point. We take the inverse, which implies that 4n plus 2 is this, in this case, is great, will be less than 1/1/2 minus epsilon. We can take here 2 epsilon, so we can take 2 epsilon with 2 here, and here 2 epsilon. We can cancel 2 with this. We take minus epsilon from here, so minus 1, and we can divide by 2. Can we find n such that this is true? This natural number is strictly less than this real number. Can we find at least one? We have to decide about the interval in which this real number lies. We start from this point. 0 is less than epsilon less than 1/2. half, we times pi by 2, we take minus, if we take minus 1 less than 0, if we add 1, 0 less than 1 minus 2 epsilon less than 1. If we take the inverse, we will get 1. Take the inverse. Here, this is less. If we take the inverse, will be greater than 1. We add minus 1 to both sides. We will get 1 minus 2 epsilon minus 1 greater than 1 minus 1, 0. Then we take 1 half. This real number is strictly greater than 0. So this n can take 0. Yes or no? The answer is yes. Why? Because n is in n, which means it starts from 0. 0 is a number that we can consider as an index or a natural number that verifies this inequality. We need just one n at least. Indeed, for n equal 0, we said that for n equals 0, 1 over 2 is strictly greater than 1 over 2 minus epsilon. The answer is affirmative. The supremum of A actually is equal to 1 half. And since for n equals 0, we find that 1 half belongs to A, this means that it is the maximum of 1. From this, the upper bound, sorry, I need this place. We can state by saying that the upper bound is the interval 1 half plus infinity. Once we find the supremum, we can decide about the upper bound. We deal now with the infimum. We suspect that the infimum of A is equal to 0. Let us deal with this. We have for all an from A, we have an is less than or equal 1 half and greater than 0. Let us verify that 0 is actually an infimum. For the first condition of the characterization for all an in an is greater than 0, and the second, for any epsilon greater than 0, can we find an a epsilon from A? Why we write a epsilon? Because the n depends on epsilon. The founded n, as in the first case, depends in epsilon. The natural number was less than a real number relative to epsilon. So we are in this case. 0 less than a epsilon less than 0 plus epsilon. A epsilon means 1 over 4n plus 2 less than epsilon. If we take the inverse here for any epsilon greater than 0, we have no cases. In this case, we have no cases. We take the inverse, we get 4n plus 2, 4n greater than, if we take the inverse, it is less, greater than 1 over epsilon minus 2, 1 quarter. Here we have an infinity possibilities to choose, and it is sufficient that we find just one. It is sufficient. We can take, for example, the integer part of this real number plus 1, and this n fits the inequality. So we are sure that the infimum is equal to 0. We are sure. From what? We can decide about the lower bounds. The lower bounds in this case is minus infinity 0. The question now, is 0 a minimum? We check if 0 is minimum. Yes, we check if 0 is minimum of A. To be a minimum, we need n such that it is equal. So 0 equal to 1 over 4n plus 2. If we times, we get 0 equal 1. This is impossible, so this is impossible. So 0 cannot be the minimum of A. Actually, I can say I finished, but I will propose an extra question. The extra question is the following. Suppose that by error, we made error in calculus, and we find that an is less than or equal to 1, for example, and greater than 0. In this case, by error, suppose that by error we found 1. Can 1 be the supremum? We check. By error we found this. Indeed, for any an from A, we suppose that we have this case. For the characterization for any epsilon greater than 0, can we find A epsilon from A such that 1 minus epsilon is less than A epsilon less than 1? We suppose that by error we found this, and we try to verify that this is true. Can we find A epsilon from A, which means n? We have 1 minus epsilon less than what? 1 over. Can we find n such that this is true? Cases. If epsilon is greater or equal to 1, this is trivial. A positive number is greater than a null or negative number. We suppose that epsilon is strictly less than 1 and greater than 0. We suppose this. Actually, we are discussing all the cases of epsilon. If epsilon is greater than or equal to 1, it is trivial. If epsilon is between 0 and 1, we are about this second case. We will have 1 minus epsilon less than 1 over 4n plus 2. We take the inverse, get greater than 1 over 1 minus epsilon. We have less, sorry, less, sorry. We take the converse. For n less than 1 over 1 minus epsilon minus 2, and we take 1 over 4. Can we find n? Can we find n? For this aim, we need to decide about this real number, in which interval does it belong. 1 minus epsilon is between 1 and 0. 1 minus epsilon is less than minus 1 minus is less than 1 and greater than 0. We take the converse. 1 over 1 minus epsilon is greater than 1. 1 minus epsilon, if we take, is greater than epsilon. Minus 2, this means minus 1. 1 quarter, 1 quarter. Final result, 1 quarter, 1 over 1 minus epsilon minus 2 is strictly greater than 1 over 5. In the case for epsilon that this is negative, the integer part will be minus 1, and minus 1 does not belong to an O. This means what? This means that we are incapable to find. We are unable, sorry, this is the word, we are unable to find a natural number which is less than this one, since this may be negative. For this reason, we cannot state that one is a supremum. If we do this by error, we find a supremum which is not a supremum. While trying to verify by characterization, we will fail on some cases that we cannot find at least a natural number such that A n belongs to A. This finishes this video. Thank you very much. See you next time.